question where a ball is given to you. This is the bowl. Okay, this is the bowl, and in this bowl, okay, this is a bowl given to you, and into this bowl a particle describes a circular motion. Into this ball a particle describes a circular motion, and this circular motion is happening in a horizontal plane in contact with inner surface of a fixed hemispherical ball. So if this is the ball, the body is moving in a horizontal plane like this. Okay, and this ball is having a radius of r, right? And that particle is at a depth d, at a depth d below its center, right? So that means the particle describes a circular motion in a horizontal plane in contact with inner surface of a fixed hemispherical ball of radius r at a depth d below its center. So if this is the center of the ball, then at a depth d below its center, okay, into this plane, this particle is rotating. Okay, so it's rotating into this fashion. Okay, going this way, then again this way, then again this way, like this, then this, okay. And the particle is basically located, it will definitely stick to the wall of the, this is the particle, right? Now if you want me to read the question again, I can read it out. That particle describes a circular motion inside a bowl. This is the bowl. Okay, inside the bowl this particle is just moving around the circular bowl, right? And this is rotating horizontal plane in horizontal plane in contact with inner surface. So this is the inner surface of the bowl. Okay, so this particle is in contact with the inner surface of the ball, it's rotating, right? Now this ball is having a radius of r, so this value is known to you. This is nothing but it's equal to r. This is given to you, right? Whose edge is horizontal. You can see the ball's edge is horizontal, right? And the velocity of the particle we need to find. That means at this point the velocity of the particle need to be calculated, right? So students, you can see at this point, which is at a depth d from the center, right? If you draw this line, if you draw this line, then this will also be equal to the radius r, right? Let me write it as o, this as p, and this as l, right? Then as per the question, the length of OL is given to you as equal to d, because particle rotating at a depth d, right? And OP is equal to capital R, because this will be the radius along the surface of the ball. Wherever the particle will go, it will be at a radius r, but this is rotating at a certain depth d, right? This is the condition which is happening, particle moving in this way. Why, when I'm drawing this line, blue line, you just think that this is sticking to the inner surface of the bowl, right? This one. So that means the particle will rotate again, touching the wall again, going this way, this way, this way, this way, like this, right? So anyway, now this movement is happening. Now let us say this particle is making an angle of theta from the vertical line, right? From this point, you can see that if this is the point of contact, then definitely this will be the line of normal reaction, right? N is the normal reaction. So if N is the normal reaction, then we can say that along this line the normal reaction is passing, right? This is nothing but normal reaction. Let me write, this is the normal reaction which is against the weight of the body, right? If this is N, then what will be the OL? OL is nothing but it's D. So if N is here, theta is here, then we can write that N times cos theta, N times cos theta, the component against OL will be equal to the weight of the body, isn't it? So if this is mg here, you can see if this is mg here, right, then n times cos theta already written is equated with mg, isn't it? Because n times cos theta is the component which is acting along mg. So this can be equated. N cos theta is equal to mg, right? That is the weight of the particle. From this, you can also see this is happening for cos theta, n cos theta. Now what is the component of n sin theta? This will be here, right? This is n sin theta, the component along this direction, that is towards the outer surface, okay? And this n sin theta, this n times sin theta, the component, horizontal component, is equated with mva square by r. That is, mva square is the component like here we have mva square by r, the centrifugal force, mva square by r, and this mv square by r, this mva square by r, right, is happening at r sin theta, this one, because this is the radius of rotation. Radius of rotation is nothing but r sin theta. So n sin theta, this component, the horizontal component, can be equated with mv square by r, and instead of r is basically this one, but this particle is rotating into this circle, and the radius of the circle in which the particle is rotating is having a radius of r sin theta, right? R sin theta is the radius of rotation, right? This is the radius of rotation. You can see this one is r sin theta. If this is r, the component LP, let me write, LP is equal to r sin theta. Now from here and from both the equations, if you divide it, then we can write n sine theta as equal to mv square by r times sine theta, right? Divided by, if you divide the LHS with this component, equation number 1, then what will got? Hi Broly Mac, very good morning. So if you divide by equation number 1, equation number 1 is nothing but this one, n cos theta. So if you divide by, let me write in a different color so that you can easily understand. Then we can write n times cos theta is which is equal to mg. Just divide the above equation, that is this one, with this. Then we get n sine theta as equal to mb square by r sine theta divided by n cos theta equal to mg, right? That means we have divided both of these equations. Now here you can see n will be cancelled out, even m will be cancelled out, right? And sine theta by cos theta is nothing but tan theta, right? So we can write that tan theta into g, right, is equal to v square by r sine theta, isn't it? And this will give you the value of v square as tan theta into g, this r sine theta from RHS denominator going into the LHS into r sine theta is equal to v square, right? Now Jai Mata Di 7352, hello, good morning. So here we can see the value of the velocity which we are going to calculate will be the value of tan theta into g r sine theta. But what is the value of tan theta? Just place the value. Tan theta is nothing but LP by OL. Tan theta is nothing but its LP by OL, right? This is the value of tan theta. So what is LP? LP is, if this is R, if this is D, OL is D, OP is R, and then LP from here we can write, you can write LP by applying the Pythagoras. This length LP can be calculated as root over of R square minus D square, right? So LP is root over R square minus D square. So for tan theta, it's LP by OL. Why it is LP? LP is root over R square minus D square. So just write it. Root over R square minus D square. This is the LP divided by base OL, and OL is D, right? This is the value of tan theta. Tan theta is this one multiplied with G multiplied with this sine theta. What is the value of sine theta from this triangle? Just refer this triangle. So from this triangle, sine theta is n PL by OL. And what is PL? PL or LP? LP is this one. So just write root over r square minus d square divided by OL. OL is nothing but, sorry, sine theta. Sine theta is PL by OP. OP. And OP is nothing but the radius. Okay, just simple. It's a simple Pythagoras and sine theta cos theta, putting up the value. And this is equal to V square, right? Now when you just multiply root over r square minus d square and root over r square minus d square, this will be giving you r square minus d square. Root will be eliminated. Into g, this g, whole divided by dr. D times r, right? So you can see earlier it was a r over here, right? So this r which we missed over here, this r will be multiplied and this r will be cancelled. This will give you g times r square minus d square divided by d. And when you take the square root into both the sides, when you take the square root into both the sides, root over of g times r square minus d square divided by d is the value of v. So this is the velocity of the particle which is rotating inside the ball, and the radius of the movement of this ball inside this particle inside this bowl is g root over g times r square minus d square divided by d, right students? So in this way this question is solved and the value of v, velocity of rotation of this particle, is calculated, right? V is root over g times r square minus d square divided by d. So let me quickly take up the question. This particle while rotating in a circular orbit touching the surface of the hemispherical ball, but the inner surface. I am just treat this hemispherical ball as transparent. And from here you can see that yes, this ball is rotating at a depth of d and touching the wall of the bowl. Then definitely this is following this path, and if we follow this path, the radius of the rotation of this particle inside the ball is nothing more than nothing but is not happening at a radius of r, but this radius of rotation of this particle inside this ball is happening at a depth d from the center, and the radius of the rotation is nothing but it's equal to r sine theta. This is the radius of rotation, right? If r sine theta is the radius of rotation, then if you remember the circular motion, mv square by r is the value of the centrifugal force. Then this particle will be pushing the wall of the bowl with a force of mv square by r, right? So the formula will be mv square by r, but instead of r, which is radius over here, into the denominator the value of the radius over here, will be not r, but it will be r sine theta. This is r sine theta, r times sine theta. Let me write it properly. So that's why mv square by r will become mv square by r sine theta, right? This will be the centrifugal force which is compensated by the component of the horizontal component for this normal reaction, right? The horizontal component of this normal reaction. Hello Rajiv, thank you. Hi Jai Mata Di. 7352, good morning. Hi Brawley Mac, thank you for being connected. Yes, so here you can see this centrifugal force which is happening on the wall of the bowl will be compensated by the normal component of normal reaction. The component of normal reaction will be equal to n times sine theta, which will be towards inside, right? I just marked it for radius, but the component of the normal reaction will be n times sine theta. So n times sine theta will be compensated by the centrifugal force, mb square by r sine theta, and this is r sine theta is the radius of rotation of this particle, right? So when you just, we have already proved n cos theta is equal to mg. The component of normal reaction in the vertical direction is mg, right? And n cos theta equal to mg. So n cos theta equal to mg and n sin theta equal to this much. Then divide both the equations. You can get n sin theta by n cos theta into the LHS, which is equal to mb square by r sin theta, the RHS of this equation, divided by RHS of the above equation. So here m and n will be cancelled out, and when you solve it and put up the value of tan theta and sin theta, because in this triangle you know the value of OL is D, OP is R, right? This OP, this radius is R, right? This LP, if this is P, right? LP is nothing but LP is root over R square minus D square, applying the Pythagoras we have calculated. Now just put up the value of this tan theta, put up the value of this sin theta, right? And G and R is already there. Here R and R will be cancelled out, and tan theta is root over R square minus D square by D, because tan theta is LP by OL. Tan theta is LP by OL. Let me write it. Tan theta is equal to LP by OL. What is the value of LP? Here, root over R square minus D square. We have written it, divided by OL. OL is nothing but a small d, multiplied with a small g, then capital R, which is already cancelled out. Now root, what is the value of sin theta? From here, if theta is this angle, sin theta will be equal to LP by the radius, right? So what is LP? LP is root over R square minus D square. By Pythagoras we have written. This is LP divided by hypotenuse. Hypotenuse is R, right? Just solve this. You can see R will be cancelled out, and root over R square minus D square becomes root over R square minus D square. This is coming 2 times, so root will be eliminated. So it will be R square minus D square divided by D, and into the numerator is G. And when you take the square root into both sides of the equation here, then V square will become V, right? And the value of V is calculated as root over of G times R square minus D square whole divided by D. This is your answer, students. Thank you so much for watching. Be connected. Happy learning. Take care. Bye bye.